Hi, today we're going to take a look at the ST STM32 ARM Cortex-M3 chipset and a very low-cost development tool for this. This is basically for me to get up to speed for the STM32 ARM Cortex chipset, the development system, things like that, because one of my new products is going to be using this chip, and I'll mention that in a minute. Now, I've got a new setup today. I'm obviously doing a webcam capture here at my desk, and I can do funky stuff like go over to my screen capture and embed my little head down in the corner, and hello, I can play around with the actual board. And this is the board that we've actually got here today. It's the, let's go over. It is the STM32 L Discovery Kit, and this thing is only... Here it is. It's only $13.83 on DigiKey, so it costs bugger all. I got it from local Farnells. It costs a bit more, but they had it available. So it's extremely low cost. They're practically giving the thing away, and it's a very powerful micro, which we'll take a look at. Now, this is what we've got, the STM32L Discovery Kit. This is for the STM32L series, not to be confused with the regular STM32 series ST, and most of the manufacturers out there have a plethora of different chipsets and different series, and there's subtle variations between them. But this is the L, and if you might be able to guess what that stands for low power. And some of the features, this is why I'm particularly choosing this chip, as I'll go into in a minute, is its low power functionality. But this is a nice little board with the chipset, the programmer and debugger built in, and also a little LCD as well, because I'm using it in an LCD application. And we're going to try and get this thing up and running and see what it can do. Now, somewhat confusingly, this is the 32L152C, and that is different from the actual chipset I'm using in my product, which is the D chipset, the 152D, and they are different chips. You can actually get a development board for the 152D, but it's like $300 here, and well, yeah. No, but this C version here is practically an identical chipset, and it's $13. It's just crazy, and it's got an in-circuit programmer built into the thing as well. And if we actually have a look at the datasheet for the differences between the 152D and the C one, they're basically very, very similar. The only difference is that the D version that I'm using in my product comes in, well, it's got more memory. It's got 384K of flash, but it comes in 144-pin LQFP package there, whereas the C version that we're looking at only goes up to 256K and only goes up to 100-pin QFP package. But apart from that, they're, very basically identical chips, really. Now, let's take a look at some of the functionality of the STM32L chipset, and obviously ultra low power. They've put that like first, right up the top of the data sheet. There's a reason for that, is because it is pretty darn low power, and it operates from 1.65 volts to 3.6 volts, 290 nanoamps in standby mode. It's got 3 different wake up pins, 1.15 amps, microamps, standby mode, including the internal real-time clock. That's very good. 440 nanoamp stop mode, and it can use 16 different lines to wake the thing up. Like if you press a button or something like that, that's what the wake-up lines mean. If you hook up a button to one of the external inputs, for example, you have a keypad, then that can wake it up out of that. And it's got an 8.6 microamp low power run mode, so that'd be using the internal like 32 kilohertz oscillator to do that. But when you're using external crystal, 185 microamps per megahertz run mode. The D version is actually a bit more. It's 230 microamps per megahertz in run mode. It's a bigger processor. It's got more memory and stuff. But apart from that, they're pretty identical, and 10 nanoamps I/O leakage and all that sort of stuff. Anyway, it's an ARM Cortex-M3 processor, works from 32K up to 32 megahertz. Yeah, the MIPS per megahertz if you're into that sort of thing. It's got a memory protection unit, blah, 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 ultra low voltage detector, all that sort of stuff. It's got an internal 32 kilohertz oscillator with RTC, and it's also got an internal high-speed oscillator as well, plus minus 1%. That's pretty darn handy. And as I said, the low power 37 kilohertz, 30, I think I said 30 before, 37 kilohertz RC mode, and it's got a internal PLL as well for USB operation. USB and UART are supported for bootloaders and things like that. Fantastic. My product is going to use a bootloader and load firmware images from an SD card, which I'm going to hook up to it. So you'll see more about that in the future, no doubt. JTAG, trace debugging, all that sort of stuff. 70 IOs of 5 volt tolerant, so that's very nice. So you don't need any interface voltage translation chips or anything like that. It's got 32K of RAM. This version that we got here for our $13 board has 256K of flash memory with ECC. It's got E2 PROM built in, which is one of the advantages that I will be making use of. And also a big reason why I chose this chip in the product is that it has an LCD driver as well, 8 by 40 segments, which is pretty much what I need. I think I need like 36 segments or something like that. So, and it's got decent analog stuff as well. It's got 2 op amps built in. Not sure of the performance of those. I don't think I'm going to be able to use those at all. 12-bit ADC, excellent, at 1 meg samples per second with 25 channels. Fantastic. It's got a DAC as well. A lot of micros don't have DACs, but it's got a 12-bit DAC with a 2-channel DAC. Awesome. So you could do like stereo audio or something like that, perhaps, with output buffers, and 2 ultra low power comparators as well with wake up capability. DMA controllers if you're into that sort of thing. USB 2, 3 UARTs built in, 8 up to 8 SPIs depending on the chip that you use, or 2 I2Ss. It's got 2 I2C buses, 11 timers, blah blah blah, 6 16-bit timers, all that sort of stuff. And it's got capacitive touch sensing as well, up to 23 channels, and CRC calculation as well. So as you can see, it's a very powerful and versatile micro. So, and you can get the development board for $13. Amazing. When I was a boy. And just as a bit of background, my original product design actually used a PIC 24. It used a 24 FJ64GA 310, and I've actually got several prototypes here actually using that. But we decided we needed more memory, more functionality, all that sort of stuff. So we looked to move to the 32-bit PIC, and well, the PIC 32MX, and I like them. They're decent parts and things like that, but the problem is, you'll notice the features here, nowhere does it really mention low power. It's got a bit of power management modes, but like, it's not tooting its own horn when it comes to that. And you read the datasheet here, where, you know, they're not tooting the horn of the low power functionality, whereas if you go to the datasheet for the STM, look, STM32 Ls, there it is, bam, these are low power parts. They're selling that. It's the big selling point right up there. It turns out, I think you have to go, I won't go into it, but I provide links down below if you want to have a look. The PIC 32 MX 3 something that we were looking at using actually has like 5 times the power consumption or something like that. It's a huge drastic difference, and that power consumption is really very important in the product I'm developing. The other thing about the microchip one, the 32, is that it did not have a built-in LCD controller, so we would have had to use an external LCD. But the company I'm doing this design in combination with, they had used an external LCD controller before, so that wouldn't have been a drama. But the original PIC 24 I actually had the LCD driver built in, and it actually had the nanowatt XLP thing, and it was very low power. In fact, slower power than STM32. This is 150 microamps per megahertz run mode, and if you remember, this one was 185 microamps per megahertz run mode. So technically, the PIC 24F lower power, 400 nanoamp real-time clock and calendar operation, 400 nanoamps. If we go over to here, it was standby mode plus RTC. There you go. It's like almost triple the consumption, but it's still bugger all. The STM32 L series in particular, still more than good enough to meet the specs. But if you're going for real ultra low power, like the best you can get in the industry, you probably wouldn't be using something like this. But for my purposes, good enough, and it's probably, I don't know, 3 to 5 times better than the PIC 32. And it's got all the LCD driver and everything built in. Beauty. Now you might be asking, what do we need to actually program these STM32L micros? Well, you only need one of these things if you don't have the development board. You only you get the STLINK V2 here, it's called, and it's $22.61, and it looks like you get all the adapter cables and serial cables and everything with it. Beautiful. It costs bugger all because, as you'll see, there's bugger all in here. Now there is actually an ISO or ISOL version of this. This is just exactly the same thing, but it has an isolated USB port in it. And if you're worried about, if you've got a ground reference product and things like that, how not to blow up your oscilloscope, I've done a video on that. I might have to link that one in. Then you want the isolated version. But anyway, the good thing is that this kit comes with essentially that thing built in. There we go. Onboard ST-Link V2 with selection mode link to use the kit as a standalone programmer. So I don't even have to go buy the program. If you've got this development board, you'll notice the header on the side here, and we can go over to here. You'll notice that the header, there it is right there. And that can, you can just jump that over to your product and it does exactly the same thing as the programming tool. Unbelievable. So other stuff we've got on here, it can be powered from the USB, as we'll find out. We'll plug it in a minute. We can measure the chip current, the IDD current. Fantastic. That's what the little jumper link down there will be for. It's got a alphanumeric LCD on there, a 14-segment LCD on the thing, and it's got LEDs and push buttons and stuff like that. Anyway, it's exactly what I want. Uses the chipset, allows me to play around with the software programming tools and measure current consumption and typical current consumption and stuff like that. So, winner. I like it. Let's power it up, see if it does something. Hopefully, it comes pre-programmed. And if we actually have a look at the pack that it came in, there's nothing else in there except the board, and you wouldn't expect it for $13, but it looks like it has some operational stuff on the back. And here we go. I'm going to plug it in, and hopefully it does something. It says to put the link in. Well, there's different positions. We'll plug it in there. Ta-da! Look at that. There we go. Discovery. Boom. JP1 is on. That's JP1 there. You can probably see that. And we've got lights flashing, and it's measuring the supply voltage. So obviously it looks like it's got a 3-volt voltage regulator on there, and that is very nice. So let's just repower that or reset it. Yep. Beautiful. And can we play with the slider? No, slider doesn't do anything at this stage. Let's see if we can change mode, shall we? Sorry, I've got this propped up on a box. And I have no idea what that means. Not quite sure. What's that? It's not some sort of counter. Hello. Sleep mode. 0.0. Run mode. It looks like it's cycling through and measuring the power consumption. This is fantastic. This is great. Sleep mode. 260 microamps. Run mode. Ah, beautiful. Let's push this again. So it comes low power run mode. There we go. That's using the low power oscillator. 3.7 microamps. Low power run. 7.6 microamps in the low power run mode. There you go. And the card here actually tells you what the different modes are there for the autofocus on my Logitech C920 webcam's not working that great I had to set the other one manually, the one on the left there for the board. Anyway, you've got the different modes, and that's great. It measures. I didn't expect it to measure the power consumption. I thought I'd have to take the jumper link off. That's very common on these development boards. You take the jumper link off, and then you insert your current meter in there and measure it. But that's terrific. Beautiful. It's exactly what you want. If you're into low power, if you want a low power ARM processor, this one's great. I presume that's a live measurement. Let's see if we can find the schematic. Let's press that button one more time though. Do we go into another mode? No, what's that? These are all the different modes. I mean, these modern processors have so many different modes on them. Standby. Yep. Standby wake up. Okay. 360 nanoamps. Beautiful. I love to know if that's a real live measurement of that. Anyway, we're back. There we go. Back from the future. Let's change the jumper link here. It restarted the processor because it interrupts the thing, and it looks like, is there anything different? It's the same. That's the same. That's different. It's milliamp mode. It's displaying the current in milliamps now, 0.03. Yeah, 30 microamps. So it looks like jumper up is microamps, and jumper down below is milliamps. So there you go. Oh, no, well, it's displaying microamps now, but it's like, that's 20 nanoamps. Wow. No, it's down in the... That's interesting. I want to have a look at the schematic and see exactly how it's measuring this and doing this, because there's nothing else on the board. You'll note that it's got the main processor. The external crystal isn't fitted, so if you want to put in your own external crystal, no worries, you can. It's got a 32 kilohertz external crystal here. It's hard to do. I should not look at the screen. 32 kilohertz external crystal, and there's basically nothing else. There's nothing on the bottom of the board, by the way. So you can actually hook up a battery by the looks of it. That's nice. It's got some reserve stuff up the top. Don't know what that is. We'll have to read the manual, have to RTFM. I wonder if we can use the slider. The slider's got a piece of perspex on there, which is quite nice. So anyway, I love how it measures the current consumption. It's beautiful. And if I follow the link on there, st.com, STM32 L discovery, it takes me to this page here. Here it is. And this has, what's this? STM Cube L1. I don't know. They keep throwing names at me. I don't know. Embedded software. It includes low-level drivers, USB file system, RTOS. Wow. Touch sensing graphic, coming with examples running on ST boards. Cube is an STM original initiative to ease developers' line to reduce development effort, blah, blah, blah. Right. So they're called a STM Cube, and that's their initiative to ease development. I don't get it. Anyway, consistent and complete embedded software offer that frees the user from dependency issues. Excellent. All right. To play here, STM Cube overview. Ooh, we can watch this. Hopefully the audio comes through. And we've got different video showing you. All right. Anyway, it generates high-level code and all that sort of jazz, which is great. It uses high-level GUI to generate initialization code for your micro. Shush. Because one of the problems with developing for micro, especially for the first time if you're not used to it, is all the initialization and setup stuff of all the registers and everything else you need to do just to do basic stuff. So if you can get a high-level GUI interface that takes care of all that stuff for you, then yeah, great, you'll be up and running much quicker. So we can actually go down to get software here, and we can get the software, version 4.15.1, get software. Oh yeah, blah, blah, blah. Except, bullshit. Bite me. This is just bullshit. When a company's going to learn, this just pisses people off. To sign you up to, they're just going to use crap email addresses anyway, and names and fake names and everything. And like, I've now got to go to my email to get the link to now. Hate this crap. So while that's downloading, about 150 meg or so, what development tool chains does it use? Well, it uses the IAR Embedded Workbench, which I've used a long time ago in a galaxy far, far away. Keel, ARM, I don't think I've ever used the Keel software, and the GCC one as well. So there you go. But it's not like, there's nothing obvious. You know, you go to like the product page here, and there's got like, there's technical documents and descriptions and things like that, but there's nothing that sort of, you know, maybe you got to watch the videos and go through step by step, but there's nothing like download this, and it just includes like the GCC compiler, for example, by default, with all the stuff already set up for this particular micro and things like that. So it's not, you know, so for a beginner coming in, how do I use these ARM chips? It's, you know, there are certainly better options out there to actually do it. So yeah, I'm going to have to figure out exactly what I need here, whether or not I'll use the GCC or whether or not I'll use the IAR Embedded Workbench, because I think you get a free version up to 32K or something, is it? Don't quote me on that, but you get a... Anyway, I think it is. I think you might get a free version of the IAR, and maybe it's got some optimizations disabled or something like that. But anyway, I have not used the GCC ARM compiler before, so I don't know. But they do have these things, getting started with the software development tool chain document and things like that. But there is no, you know, like click here to download the software kind of thing. So it's just not there. They've got that code compiler, which I'm downloading at the moment, but that's actually not a code initialization thing, but that's just to generate initialization code. It's not, I don't believe it will include any compiler in there at all. And by the way, no schematic. I can get the Gerber files, I can get the bill of materials, so I downloaded the Gerber files, they're all there, so that's hunky-dory, but where's the original PCB file? It's not there if you wanted that. And the schematic, I can't find it. It ain't here. And if I actually go over to DigiKey here, it does have, look, there it is, the STM32 L152C Disco schematic. I click on that. And wah, 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 wah. Now, it did link through to the page for the Discovery firmware package, which is what we want. I want the code for this thing to see exactly how it's doing the current measurement and things like that. If I can't get the schematic, still don't know where that is. Look, they got some documents here, current consumption measurement and touch sensing demonstration firmware. So if we have a look at that, here it is. Here's the application note. Tells you all about it. Fantastic. So their documentation is pretty good. Here's the, look, it's got separate IDD measurement circuitry on here. So that's the, you know, block diagram. I don't have the schematic. Haven't checked further on, but ta-da! So here it is. We've got two current sense resistors there, and it looks like, look, a digital switch there that is controlled via a counter down here. It looks like a separate counter chip, because that's the STM32 L1 there, and then there's an external differential amplifier with a gain of 50, another electronic switch here. Where's all this circuitry? I was very curious, so the only place left for it was, ta-da, there it is, sneaky buggers. But anyway, is the schematic in here? Okay, no schematic at all. Bummer. Is it linked in down the bottom? Reference documents, updated clock section. Nah. But hey, this is neat. It tells you how it all works and the algorithms to actually do it. Sweet. And if you have a look, the IDD jumper JP1 must be placed in the on position except for bias current record operation. So I think we saw bias current pop up on the LCD when we had the jumper in the other position there. So what bias currents are we measuring? Because bias current is not static current. So anyway, due to compensate errors due to the bias current. Okay, right, bias current record. Okay, so that's like a calibration feature by the looks of it. Bias current. This operation consists of storing the bias current values of operational amplifier A. Hey, they've thought of everything, compensating for the error in the times 50 amplifier in there. Sweet. And bias current mode. There we go. GP1 off. Yep, you betcha. And release the switch. And it tells us the bias current. There we go. Bingo. It stored it. I believe it's now, 0.16. It's jumping around a bit. Anyway, it's now compensated. So now I repower that, and it's stored in there. By the way, this is the slider. This is a percentage slider like that. So that seems to work reasonably well. Go in there, and it's a crude slider like that. But this is a great example board. And now these are the actual measurements in the various modes. So 260 microamps there. Run mode, 740 microamps, 280 microamps. Beauty. And we can go into those. This is a winner, chicken dinner. Right, so let's run this CubeMX thing and see what happens. Next, I accept, blah, 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 blah. We don't have to use this. We can just use the compiler directly, but yeah, we haven't gotten there yet. I want to try this out. Target directory will become, yeah, right. Create shortcuts, yep, right. All users, yep, right. And here it is. Looks pretty boring. Load projects. Do we have example projects? New project. Here we go. Whoa, this is what we want. Bam, straight in. Thank you very much. Board selector. Here we go. Here's all their boards. Here we go. Discovery. Wow. 152. Where is it? STM32 L Discovery 152 Disco. That's the one. We're disco in. All right. So we can, I guess, go like that. Oh, yeah. Okay. Peripherals, connectors, selection. Initialize all IP. Oh, vendor. Oh, there's only the one vendor, ST microboards. Okay. So we've chosen our board. Fantastic. It supports, very comprehensive, supports all their development boards. Ah, isn't that sweet? Look at that. I love these GUI. Can use my mouse wheel to scroll in and out there. Look at that graphical representation for the chip. That's actually on there. It's the STM32 L152 CTX. It knows exactly what chip's on there. It's pulled it up, and now, look, can we go in and click on the individual pins? Can we do anything? No, it just hovers over and tells us what that does. Oh, there we go. Yep, so the I/O, so PB7, we can then change PB7 to do anything we want. We can change each individual pin to be configured. By default, this is what the configuration for this chip is for this particular demo board, right? So as you can see, it's already set up for all the segments, comms, and everything for the LCD. So the segments, and we're using 3 commons for the LCD there, by the looks of it, and there's the green LED and the blue LED on the board, and wow, that is great. That is excellent. So there you go. We can configure all this stuff. Middlewares, configuration, middlewares. Look in the top corner. FAT. So there's a FAT file system. I guess if we had like an SD card, it would come configured. It's got a free RTOS. I don't know what the which free, is it called free RTOS? And the FAT file system, I guess ST have written there a FAT file system which allows you to, so you can include that. Then you can go in and you can configure all your clocks. Look at the block diagram. Oh, I'm so excited. This stuff, usually when you're developing for micros, This sort of stuff is buried in page 300 of the datasheet, and you've got to go in there and look it up. You know, you've got to know that, oh, internal register such and such to select the input on this mux here. You know, you've got to do all that. But this is, yeah, there we go. I can just select which channel of my mux I want. That's nice. And then I can divide by 8 thing. So the system timer for the clocks and everything else. Wow. Wow, it's almost too powerful. You could get lost in here. But that is absolutely brilliant. That's what you want as a beginner. You don't want to, you know, going into the data sheets and trying to find this stuff is a real pain in the butt. So other configuration stuff, DMA. Okay, so there's all the DMA stuff. Not really interested in GPIO. Real-time clock. There we go. Instruction. What? There are your calibration values for your real-time clock. RCC. RCC? No, that's not RTC. That's RCC. What's that? That's something else. Analog. Not there. Why do they call it middlewares? That's hilarious. So, time base. Or there's your timer. That's watchdog. Power consumption calculator. Brilliant. So it will give you an estimate of, this is very common in the FPGA field and stuff like that, when you want to estimate how much how much current your design's going to take. Now in this case we're not, you know, generating using macro cells and things inside, but we are turning on certain functions. We are like a certain chipset peripherals and things like that. So each peripheral you turn on and enable and use is going to take extra current, what frequency you're operating at, which clock you're using, all that sort of stuff. It even takes into account the ambient temperature, which supply voltage you're doing, and you can select, look at this, you can select your battery, CR2032. Wow. Wow, so will it give you the battery life? It'll self-discharge 0.12% per month. Nominal capacity for CR2032, 225 if you've got 1 or 2 in series or parallel. Wow, this is neat. I like current consumption calculators. I'm a bit of a current consumption calculator fanboy if you didn't know. So that is neat. Like I could spend all day here, but the fact that it's got that is great. So that is an excellent configuration thing. So here we go. So we can generate the code, power, transitions checker. Oh, looks like you can do sequences and stuff. This power consumption calculator might be more powerful than I think. So it's pretty good as I thought. But yeah, look, you can add in steps. There you go. So you can add steps as you change things. So if you're going into sleep mode and things like that, it can, I believe it should be able to calculate all that. Wow. Okay, I'm thoroughly impressed. All right. This STM32 CubeMX. Winner, winner, chicken dinner. Anyway, we can generate code for all of our current pinouts. So what you do is you set up, when you've got a new project, you set up what pins do what. And like you might want to change them on the fly, of course, but this is like the initialization code. What this software does is generate your initialization code to get your micro up and running and to be able to do something when you first power it up, when you enter your main function, for example, before it gets to the main function in your code. So we can generate a report. I'd like to generate a generate code. Test. Project location, test, and then we choose our tool chain. Oh yeah, where's GCC? I get, no, that's the, okay. No, unless there's another name for it. Other tool chains. Anyway. Okay, code generator. Advanced settings. All right, let's project location cannot be found. Oh, God, give me a break. Yeah. Open. Firmware package or one of its dependencies requires not available in the... Do you wish to download this now? Yeah. Okay. Okay, why didn't it include it? Download STM Cube firmware? I don't know why it needs to do this. I'll get back to you. Okay, it downloaded that fine, took a little bit, but it downloaded and then kept going and compiling the code and generated the code. Then I could have opened the project, or in this case, I've opened the source. So here we go, main. Just open this in Notepad here, and bingo, here we go. It's generated all the code. There it is. And yep, there we go. There's our oscillator, initialisation code, all that sort of stuff. See, all of this sort of stuff you would have had to have figured out from the datasheet and done manually. Otherwise, your micro sits there and does nothing. It just won't work. And that's, a huge hurdle for microcontroller development. That's why Arduinos and things like that are so popular. It's much higher level than that. All this sort of stuff, register level stuff, is taken care of for you. But then there we go. It sets up the pins, and well, it's telling you how the pins are going to be set up, and then it goes in and it's setting pull-ups. Pull-ups and speed. So you can set the GPIO speed, you can set the GPIO pull-up, then you can set the GPIO mode. Look at, there's a lot of initialization code here that GUI has generated for you. Thank you, Mr. GUI. That is brilliant. Huge thumbs up. And on that firmware page, I was actually able to download the actual firmware source code for this particular demo board. Download it, no problems. Here's like the LCD. Here are the files on here, and we can have a look there. There we go. STM32 Discovery. It's all in there, and this is like the code for the LCD, for example, and very well documented. Here's the 14-segment mapping and stuff like that. How they actually map the things in there, and that's terrific. So all the example source code is there, so you can should be able to recompile this for yourself and then play around with this, maybe use this as a basis for your own project. But as I said before, where is like the link to just download the GCC compiler or something like that with everything set up? It's not at all obvious. It's not for the beginner, this thing. Like, this is the product page for this development board, and okay, looks like we're going to have to go in here and read this getting started with the software development tool chains. We're going to have to read a PDF document before we can just go in there at so for sort of, experienced users like me, who have used another micro, for example, but haven't really used ARM before, like this, then, I want to know, where's the programmer software, where's the compiler software, and I want it all there on the product page so I can just download it and start running with this thing. But no, looks like we're going to have to read some documents. Bummer. And unfortunately, look, this document provides an introduction on how to use the following software development environments: IAR Embedded Workbench, the Kiel one, True Studio. I've never heard that by Atomic. I don't know. Maybe there's a few Atomic fanboys out there. Or Tasking, which I know fairly well because I used to work at Altium. Tasking are good compilers used in primarily like the automotive industry and stuff like that. Really big in the automotive industry, but I don't think, outside of there it's not that huge. But really good compilers from Altium. Hi to the Tasking group at Altium, still in the Netherlands, I believe. Anyway, but where the emission? Where's GCC? Like, if I did my project, everyone will just assume that, I'm going to use GCC. Everyone uses GCC, right? It's it's the thing to use. But this is the getting started guide for this discovery board, and it does not tell you how to use GCC. It doesn't tell you where to get it from. It doesn't tell you, links to a compiled version of it. There's the STLINK thing. So, yeah, looks like we're going to have to use IAR Embedded Workbench, which is fine. I've used IAR before. They're excellent tool. I love their GUI interface and things like that. I've used it for Atmel and other ones, but I haven't used it for ARM before. But, yeah, that's disappointing that GCC is not in there. That's a huge oversight. So I'm on the IAR Embedded Workbench website, 62,000 users. Is that all? Thought they'd have more than that. Anyway, they support 11,000 devices, blah, 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 30-day free trial, blah, 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 blah. But look at this. You go to the buy page, wah, 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 request for quotation. Seriously? Are you that dumb, IAR? Just put the freaking price there, a PayPal buy it now button or whatever. Have different tiers of your software if you want. Sure, if you got need some enterprise version for 1,000 seats at your company or something, fine, okay, quotation for that. But me buying my little $15 embedded discovery thing, this is where the documents point me towards IAR. There's some others, but I come here and go, what? Quotation? What's all this? No. Fail. And it turns out they've actually got a ton of different versions just for ARM. Look at this. They've got functional safety standard, Cortex, Cortex M0, limited baseline versions, blah, 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 blah. Anyway, what we want to do is go into the free trials here and take a look. Now, here's where I said before, you do get a size-limited Kickstart license without any time limit, or you get a 30-day full, pretty much the full thing for 30 days. So you can choose which one you want. The size-limited Kickstart one, as I said before, 32K restriction. Oh, 16K for Cortex versions. So there's no source code. You don't get the MISRA C support. C-Run is not available. Don't know what C-Run is. And limited technical support. But anyway, that'll allow us to get up and running anyway. But anyway, we'll download that. And even with 32K size limit, and might not include optimizations and all the other stuff, or does it include debugging? Doesn't say anything about debugging limitations and things like that, but you can still do a lot in 32K. So yeah, that's only a 1 gig download. Anyway, I've got a reasonable connection, so it's already 1/10 of the way there. Yay! I will show you my desktop, just for fun, while we idle the time away. Look at this, there's an option for dongle drivers. I don't think I need to install dongle drivers. Did IAR come with a dongle back in the day? Anyway, I'll just install the ST-Link. Yep, you guessed it, online form to register for your time-limited or code size-limited version. Alrighty, so after loading it in, I got the license keys and all that sort of jazz. I can open a workspace, and I've downloaded the firmware, which you saw before. And if we go into the Discovery Pack firmware projects, let's look at the current consumption touch one that's inside, which is the demo that we're actually running on the board, and EW ARM. Here we go. So it's got all the different versions here. Okay, and bingo, there's the EW file. Let's open it. Will it work? My workspace is up. Yep, there we go. There we go. We're in like Flynn. And I just tried the make function. Sorry, I wasn't recording, and it went through with no errors. Okay, so it did actually make that project without error. So what I'm going to do here is I'm in the main, I'm in user and then the main.c here, and it looks like we can just change the text message that is presumably displayed on the LCD. So I might simply change that to EEVblog. I could change it to Hello World, but meh. Else, what? You'd else do that? Well, I don't know. That one can be Hello World. There you go. Oh, everyone wants the exclamation mark. And then we can make this again. So if we go into make, here we go, building tree, blah, 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 converting number error is 0. Okay, let's try and download it. So remember, I have not used this before. I've not read any instructions whatsoever. I simply loaded in the project. This is the best way to get set up. Load an existing project that compiles with no errors and then start playing around with it and then, learn that way. It's, it's one of the best ways to do it. Anyway, there's some little buttons up here. Hang on. There we go. Download and debug. Debug without downloading. We want to download and debug. I just want to download, but anyway, we'll download and debug. Oh, what? So it didn't automatically detect I installed. It was supposed to install the drivers, the ST-LINK drivers, and it just, no, not happy at all. Let's go into projects here, download and debug. Debug without download. In download active application. Well, it was supposed to be that easy. Here it is for the EEVblog toolchain, which is what I'm using. Basically, open the workspace, which is what I did. Got the example demonstration, was what I did. Rebuild all. Well, I did make. Maybe I've got to rebuild all. Anyone should have done the business. And then, but that's what I got. Total number of errors and warnings and everything. So that's fine and dandy. And then include, I didn't do project options C++ compiler. Why do I have to do that? Anyway, in the, to change the project settings, don't have to do it. There you go, download and debug. That's all you had to do, download and debug. I hit that button, it's exactly what I thought. And there you go, it's supposed to download and debug. But it hasn't, and that's it. That's the entire instructions for the IAR Embedded Workbench thing. That's it. And it didn't work. Thumbs down. Oh no, I think it's a pebcac. Looks like I missed a step after installing the EEVblog. The user should install the STLINK V2 driver. The original STLINK, not the V2, the original one does not need a driver apparently, but the STLINK 2 does. See, like, this should be on the, okay, it's in the document, okay, but it's, yeah, alright, I'll stop complaining. It's in there. I probably should have read it. So you have to do this after you install the IAR Workbench. So let's do that. So it's supposed to be in C, IAR Systems, Embedded Workbench, ARM, Drivers, STLINK, ta-da, STLINK Upgrade. No? It says to run the, no? Okay, Windows, I guess I've got to go into Windows 7. No, STLINK, nope, doesn't match the description. There you go, STLINK V2 underscore USB driver. It doesn't match that description. Okay, so I ran the batch file here and it's going to let me install the drivers. I'll probably might have to reconnect it, of course. But it may take some time to complete. Thank you very much. But once again, you know, these little things where it doesn't match the description and it's buried away, you got to, no, like, they need to have a more compelling first-time user experience. Because, you know, you can be left scratching your head if you manage to figure out how to download IAR and all that, to open the workspace and all that, you're following the instruction, it doesn't kind of work, and then, oh, what are these error messages down here mean? That it fatal error failed search for probes, ensure that the USB drivers are installed. Like, you know, yeah. It just occurred to me, you remember way back at the start where I was installing this thing and it said, do you wish to install like the the dongle, right? That dongle thing. Is that what they're talking about? Maybe? If so, that's, you know, dodgy terminology. Anyway, hopefully, it'll work now. Can we just do it? Can we just do it? Yes! Look at that! It's flashing! It's downloading! Will we get EEVblog? Hello? Run! It worked! I didn't have to reconnect it. Did I accidentally set up a breakpoint? Toggle breakpoint. I don't know. No, why is it pointing to int main there? Anyway, it downloaded. Maybe, I saw an option, leave target running. Here we go. Like, so all this is enabled now. So leave target running. Is that, no? Maybe if I hit the reset button. Hey, EEVblog. Winner, winner. Chicken dinner. So there you have it. This has been long enough. Sorry for the length of this. It was sort of like a me going through it, sort of like first try, just to see how good how easy the tools were to set up. And, well, ultimately, it took like a few hours to do this. Granted, I'm shooting a video and doing, you know, everything else, but, you know, dicking around. But, hey, you know, it wasn't the best first impression. Not suitable for a complete beginner, and maybe some things might be a little bit,
you know, annoying for like an experienced person like me, but somebody who hasn't touched the ARM tool chain like this before. So anyway, I was quite surprised that there is no support, or it doesn't look like, I'll stand to be corrected, no support for the GCC or whatever, or, you know, like, I don't know how to use GCC with this thing yet. I'm sure everyone's screaming, oh, it's easy, set up the command line, do this, do that. Yeah, whatever. Okay, I got the IAR Embedded Workbench working fine, as long as I followed the silly instructions to the letter, and installed the drivers, and everything's hunky-dory. I'm up and running now. So, you know, yeah, it's not the best first impression. I mean, if you go over to the you know, just the website for this thing, it's a little bit quirky, doesn't really have everything. It's not, you know, everything's not in the one place, stuff like that. I mean, this is the main page for the Discovery Kit, and, you know, it leaves a bit to be desired, but ultimately, you know, after a couple of hours of mucking around, anyone should be able to get a tool chain up and running for this thing. GCC or something might be a bit more confusing or take longer. They don't have the step-by-step instructions for that. I think they should. But anyway, you can get a 32K version of the IAR Embedded Workbench. You can do some decent stuff with that. Although this board has 256K, so, you know, anyway, if you want the full version, you pay the money, etc. But for a $13 ARM development board, and this part, what it can actually do is very impressive. The functionality for it and everything else, it's an absolute winner. What is the price on these? The STM32 L1 I won't include the rest of it. And integrated circuits. There we go. What do we got? Sort by price. They're not cheap in one-offs. Oh no, there we go. Yep, the 152C that we're looking at, I don't know if it's exactly the same one, but $2.30. You know, oh, actually, that's 1,500 quantity. So, yeah, we have to go down before we can get to... anyway, you know, a few bucks. It's not the cheapest, but it is a high-end, you know, quite a powerful ARM micro. And for a $13 development board... yeah, why the hell not? I like its low power modes and everything, supports LCD and all sorts of stuff, and hopefully you'll see some more upcoming videos, although supporters might actually see those videos before, or find out information on that before the regular audience, because the product I'm working on is not general knowledge yet. So anyway, that ultimately worked in the end. Just a few little quirks, the odd pebcac or two, as to be expected. So if you combine that low-cost development board, which is really nice, with the power management and the LCD and everything else, the low-cost programming tools for them easily available. They've got even an isolated version, which is very nice, which is still even reasonably priced. And then when you combine in the awesome STM32 CubeMX software, like configuration software, that's absolutely brilliant. Looks to be very comprehensive, very powerful, and then I think they've got a winner here. Combine that with the capabilities of these ARM STM chips. I think I might be a ARM STM32 fanboy. I certainly like this low power series anyway. Very comprehensive capabilities, so well worth a look at it if you're into develop. There might be ones that are slightly easier to get started, but this one's very compelling, the ARMs. No worries. Anyway, I hope you enjoyed that. If you want to discuss the ARM development tools and tell me, Dave, you're doing it all wrong, yeah, go ahead. Comments down below. Catch you next time.
Hi, in this video we're going to take a look at a couple of affordable FPGA starter kits to get you into FPGAs. But before I jump into that, I thought I'd just do a quick little primer here on exactly how easy is it to hook up and use an FPGA. As I mentioned in my previous videos, which I'll link in, the answer is not very easy at all. Take, for example, your classic microcontroller here. You pick your AVR, your